Assalamu alaikum. On behalf of EMC, I would like to thank and congratulate the organizer and Your Excellency for making this forum possible. We believe it's very timely to get together and discuss some of the important challenges, the digital tsunami that my colleague referred to. So my name is Zaher Haydar. I lead a pre-sales organization in the Middle East and Africa. And in the next half an hour or so, I would like to build on what my fellows speakers presented in the morning about what are the technologies happening leading into the cloud. And I'd like to just go over the major technological trends that, that will help us build this new cloud-based IT. All right. Can you hear me? One? Okay. So we've seen in the previous presentations that we are now heading towards what we call the third generation platform. Not we as EMC, the industry has started referring to as the third generation platform. And it's essentially, it's the summary of all the changes that are happening in the IT. That includes, obviously, the cloud technology. It includes the big data phenomena. It includes the mobility of IT. Also, the social aspect of the big data is into the picture. So, as you can see here, we moved from the first generation, that was the old mainframe days. We moved into the second platform, and that was the mini computing era. And now we are moving into this third platform where we have billions of applications and billions of users and devices accessing this data. So if you want to summarize what's happening, we can say that in simple terms, IT is being transformed, okay? So there are changes already started. It's not starting today. It has started, and the changes will continue for the next few years. If we go over what are the key changes and the key disruptive IT trends, will be the following four on the slide here. Mobility, as we mentioned. Cloud, it is a de facto. We have to build our IT in a cloud-ready manner. The size of the data, we heard different statistics this morning. Some people said 35 zettabytes, some people said 40. We believe 40 is closer to the actual figure, but anyway, this is a speculation. What we know about is that the data is growing so fast beyond all our predictions and beyond all our expectations. And it is so the social factor is feeding into this growth of data at a large scale. Now, trust is a significant element of everything that we do in IT, because we cannot build IT around our data and our information if we cannot trust either the quality of the data or the safety of the data, or that it's properly protected against any kind of threat. So we, at EMC, we have reorganized ourselves recently as a company around these trends in the IT. So I would like just here quickly to share with you what is our new EMC family in 2013. It is built around these challenges. So at the bottom, obviously, we have EMC Information Infrastructure, which focuses on building infrastructure solution from data storage to data protection, and various computing solutions. A sister company, which is VMware, takes care of building the cloud operating system, which will be the building platform or one of the major building platform for the cloud data center. We have created a new entity called Pivotal, which is focusing on building a platform for the big data and for the new applications that will be required in the cloud era. We have a significant component of the family focusing on content management, on document management, case management, etc. It's focusing about the quality of the information and how to be leveraged in the business. And on the top of everything, there is a a set of solutions that are targeting how we can enable the access from any device to any of these applications or to any of these components of the data center. And this is basically the new form of the client devices, which can be the mobile, the tablet, et cetera, et cetera. So when we say IT is transforming, obviously that transformation is leading into transformation of the infrastructure. So how is the infrastructure transforming? You heard this morning about a new term that surfaced in the industry last year in 2012, the software-defined data center. Essentially, the traditional data center that we were referring to, and that was the virtual data center in its latest incarnation, now we are talking about using standard hardware across all the layers of the computing layers. That includes the servers, that includes the network, the storage, and putting all of this in a pool where everything can be automated based on built-in intelligence. So how does this really work? It works by having kind of an umbrella suite of intelligent software, and that's what defines the data center. And that umbrella of software is actually, it's actually communicating with a new form of software-defined networks, software-defined compute, software-defined storage, and software-defined security. So the idea is that the components themselves, they will be more intelligent in order to be plugged into this new software-defined data center. And we'll talk a little bit more about what it means for us from EMC perspective. Now, there are a very important component of building this new software-defined data center is a new way of acquiring the components themselves. So traditionally, we used to acquire the pieces, the compute, the network, the storage separately, which is okay, but it requires some integration efforts, and usually it increases the time to market for any solution that we need to build. The converged infrastructure or the converged compute will be a perfect fit for building a new software-defined data center because we acquire all the components in one bundle. All the components are integrated together. It helps us in getting faster to market and increasing the reliability of the solution that it will work when we put it in effect. So one question that we can ask ourselves, what do we expect out of this? Why would we want to bother, let's say, by even transforming our IT? So back in 2008, we were using standard component, mostly physical servers, and there was no virtualization for network or anything like that. And whenever we needed to provision a new application or new service, we were basically talking about weeks and days because there was different departments, they need to talk to each other, and there's always some integration mechanism required. With the virtualization, and that was a significant improvement to the way we procure IT and the way we implement IT, we went down from days and weeks into potentially hours and days. Now with the software-defined data center, which is the ultimate in automation, we think that we can actually procure and implement a new service in minutes and possibly in seconds, which is really important for this new cloud age that we will be able to add services or remove services quick and fast enough. So that's the promise, and that's where we are heading, and we don't think that we are far from this ability. Now, an important piece in the data center, and it keeps getting more important, luckily for us in EMC, is the storage, because with the increase of data, we need more and more capacities in order to store them. So there are lots of changes happening to the storage technology itself. So some key important changes is related to, first, going into a scale-out architecture. So that's a term that, again, is becoming an important architectural element of the storage. So traditional scale-up architectures are not really suitable for the cloud or the big data. They usually reach a point where they cannot scale anymore. Okay? So this is why we need to go into scale-out architectures, and this is something that EMC has been investing heavily in the past few years. There's another element that is equally important, is moving away from traditional mediums such as tape toward disk. So tape was a significant part of the storage infrastructure in the old data center. With the increase in capacities and the speed demand and the throughput demand, disk is replacing it, and there is a newcomer to the data center is flash. Flash is going to help us significantly in managing the growth of data while maintaining good performance levels expected from the storage infrastructure. So flash is becoming quickly an important component in the data center, and it can be either on the server side or the compute node side, or it can be in the storage side. So there are different types and different levels of usage of flash technology. Now, some people might imagine that we no longer need the mechanical disks, that we can just jump into flash and assume that we will store everything on flash. While this would be nice, unfortunately, it's not feasible yet economically. So this is based on the latest pricing estimates for flash technologies in the market today. So flash price has dropped significantly over the past 5 years, and that's good news. However, when we still compare the large capacity, say the disks compared to flash, they are still 40 times cheaper than flash. So that means for storing these large amount of data, we still need the traditional mechanical disks, and we need to find a smart way of using the flash, and that's what we call hybrid arrays. So by intelligently putting a small percentage of flash inside our storage systems, and with the proper automation software running on these systems, we can significantly improve the performance. So for the next probably few years, for the next 5 to 6 years, we will continue to see a lot of the SATA disks in our data center with a little bit of flash that boosts the performance to the levels required by the new data centers. Now, there are special use cases, there are special applications that require a little bit different type of flash, and you can expect to see in the next couple years talking about the all-flash array. So for some specific application, and that could be the really highly sensitive application to latency, you will start seeing flash arrays appearing in the data center. Now again, the key is integration, and that's what EMC is working on, is making sure that these different components are able to be managed as a single pool rather than being separate components. Now, to conclude with the storage transformation, and probably this is the most fundamental part of the storage transformation, is what we call now software-defined storage, which makes it ready for the third platform. So all the storage infrastructure hardware, and I refer here to the bottom of the slide, which could be from different, obviously, vendor, from different brands, they will be controlled by a special intelligent software that allows the different storage function to plug into the cloud frameworks. So today on the market, there are multiple cloud frameworks. There is obviously one framework offered by VMware, which is a sister company of EMC, but there are others offered by Microsoft, and there is an open standard, which is OpenStack, offered also and commonly used in some countries. So the idea is that whatever is your storage infrastructure, you will have this, call it middleware if you want. So that's the bridge between your infrastructure and between any cloud model you choose to use. And that's actually the realization of software-defined data center, because without this, we cannot really talk about software-defined storage. So EMC, in our EMC World event 2 2 weeks ago, we announced the release of this software. We call it Viper, and expect to hear more and more about this type of solution because it's key component of building that software-defined data center. Now, data protection itself, which is transforming, so the storage of data is transforming, the data protection is transforming. We've seen for the past 5 years the reduced usage of tape and the increased usage of disk for smarter ways of backing up data. Now we see a lot of what we call continuous data protection and continuous data replication, which converts your traditional replication technologies into something like, we call it DVR, the digital video recorder. So you are always protecting your data. You can go back to any point in time whenever you need to, and that's the latest and greatest in the replication technology. So that's happening again. And one of the most important also aspect of creating the virtual data center is creating active data center. So traditional replication solution, they allowed to have active passive data center. With the active technologies, these are which are component of the virtual data center. Now you can really leverage all your assets appropriately. Security is being transformed. The threats that we see, we've seen, let's say 5-6 years ago, that we could maybe fend by using intrusion detection system or maybe some virus software are no longer enough. These technologies are no longer enough. The threats are becoming more advanced, and they can be either internal or external to the organization. And that's why we start talking about security analytics. So the idea is that we need to be able to detect and report on any security threats. We need to investigate and analyze the security threat, and then they make the decision based on this. So this leads into a kind of marriage between the traditional security and big data, because we need to get feeds from the different component of the data center, put it all into an analytic engine, and then based on this, feed it into a policy engine or governance engine that allows the organization to protect its asset, whatever is the threat, whether the threat is internal or external in real time. So again, the security of the cloud era is a little bit different. It's also changing, and it makes the cloud feasible from security perspective. Now, the last point I'd like to spend a couple minutes on it is that the platforms themselves are changing. So there is the change in the data center infrastructure, there is the change on the storage, there is change on how we protect the data and how we manage the data. But probably the more difficult and the most fundamental change will happen at the platform and the application. So going back to the mainframe days, we had the traditional applications which were probably based on COBOL or something like this. We didn't have relational databases at the time. It was simple VSAM or something like that. That was characteristic of the first generation or the first platform. In the second generation, we started seeing the relational databases, and we started seeing the traditional ERP, CRM application, and these were characteristics of the second generation. They used to run on Unix and the mini computers. For the new cloud area, we need to see new applications that are able to federate across different data center, and probably we heard in the morning about hybrid clouds. So that application should be able to run either internal in the data center or on a service provider. There is a new way of managing this unstructured data. Relational databases are not enough, so we need, again, new form of databases. And that's what's happening, really, because the needs of the enterprise are changing. So on this slide, obviously, what we are showing is that at the bottom, the data center will run on different cloud frameworks. Again, it could be OpenStack, it could be Amazon, it could be VMware, or something new that will come up. The enterprise will need to run applications on any of these cloud technologies. They will need to deal with large amounts of data and take decisions in real time. They need also to integrate with some legacy applications. So it's not possible to just drop our applications immediately and go into a fully new framework. So that basically defines the need of a new platform, and this is what essentially EMC intended to address when we created a new sister company, Pivotal. Pivotal is essentially focusing on creating that new platform, which is the new form of managing the data and replacing the traditional databases, a relational database, with something like shared nothing scale-out databases, a new way of creating a fabric for applications to run across different entities and across different data centers, and a link between the cloud technologies and the application, which we call the cloud fabric. So this is probably the most fundamental change that we'll see for the next few years. It will touch the way applications are built and the way the application will process the data and access the data. So in summary, obviously the IT is transforming, and there are lots of components of IT are transforming. This will take us to the real realization of IT as a service, where we can start running as a business rather than being just a set of departments. And we at EMC, and I think the other speakers referred to this, this is a journey. The journey has started a few years back. It will probably continue for the next few years. We are ready to work, obviously, with your organizations in order to create this agile IT, this efficient IT that gives you the control and gives you the choice, whichever is the platform that you decide to choose. Thank you very much for listening. And